This meeting is being recorded.
So once again, welcome everyone. This is Mudasar, and today we are going ahead with topic quorums and ended handoff. Before we move ahead, any questions or any queries, anyone that wishes to discuss anything? Okay, cool. Let's move on. Sloppy quorums and ended handoff. Databases with appropriately configured quorums can tolerate the failure of individual nodes without the need of a failover. They can also tolerate individual nodes going slow because requests don't have to wait for all n nodes to respond. They can return when W or R nodes have responded. Okay. These characteristics have make databases with leaderless replication appealing for use cases that require high availability and low latency, and that can tolerate occasional stale reads. I think this is a very important part. Good. I hope everybody is agreeing with this. Any point of time, anyone has any doubts or questions or queries, please voice it out. We will have an open discussion. However, quorums, as discussed so far, are not as fault tolerant as they could be. A network interruption can easily cut off a client from a large number of database nodes. Although those nodes are alive, other clients may be able to connect to them. To a client that is cut off from the database nodes, they might as well be dead. In this situation, it's likely that fewer than W or R reachable nodes remain so that the client can no longer reach a quorum. I think so. This paragraph talks about the situation where the nodes go below W and R. So, and that could be possibly because of the network interruption, due to which certain nodes are disconnected and we are getting a lesser W or R count, and hence the quorum is unable to be reached. Cool. In a large cluster with significantly more than n nodes, it's likely that the client can connect to some database nodes during the network interruption, just not to the nodes that it needs to assemble a quorum for a particular value. In that case, database designers face a trade-off. Is it better to return errors to all requests for which we cannot reach a quorum of W or R nodes? Or should we accept writes anyway and write them to some nodes that are reachable but aren't among the n nodes on which the value usually lives? Okay, interesting. The latter is known as the sloppy quorum. Writes and reads still require W and R successful responses, but those may include nodes that are not among the designated n home nodes for a value. By analogy, if you lock yourself out of your house, you may knock on the neighbor's door and ask whether you may stay on the couch temporarily. Okay, so let's understand this a little better. So I mean, I get this part where the options here are either to return error codes when the quorum is not reached, or we accept the write anyway and write them to some nodes that are reachable but aren't among the n nodes. So I'm not getting this statement. Yeah.
So when it says aren't among the n nodes, it means, I think, so because n nodes are the nodes which are almost equivalent to each other, isn't it? So whatever the data they have, they are almost in sync with each other. So now the sloppy quorum he's talking about in the next line, what he says, that he might pick up a node which is not from the home nodes of n home nodes. So that will be a different node. Is that what it's trying to say? In that case, if it is, so it might not be updated.
Correct. You won't get the consistent data in sloppy quorum, right? Let's say 3 were supposed to accept the write. So even write is accepted on one, it would be considered that you are done, right? Or This is
what
what
I'm
sloppy quorum.
I think what I'm gathering here is that we obviously have n nodes, but what it is trying to tell, in case of a failure, some additional node which is not part of the n nodes, the original designated n nodes, that somehow is getting introduced here. Or should we accept the writes anyway and write them to some nodes that are reachable but aren't among the n nodes, right? So there seems to be some kind of additional nodes which are not part of the nodes which are replicas. I'm still trying to figure this part out when it says that aren't among the n nodes. But my thought process here is saying that the number of replicas that we have, the n nodes, it's apart from that. So is it like they keep a standby nodes or something like that? Or
Yeah, I think
how is it?
what Shashank says, it makes sense. So the N nodes are the same nodes what we are actually always referring to, maybe for W or R. And so when any of the node actually goes off from that N nodes, so it's going to take the node which is not in that N home nodes, but it might be a different node. So it doesn't care, if the data is updated or not for that particular key, because the sloppy quorum actually goes with saying that he's storing the data in a different data set altogether, and it is only for just a short period of time. So
So this is
wherever
to
is stored
make,
is fine.
I mean, this is to make sure that system is highly available, right? It's
Yeah,
not like
highly
that.
available for write.
Correct. Although consistent might not, you might not get the consistent data, but that is what hinted handoff is, right? In place of that node, somebody else is taking up the rights. When that will come, he'll write over there.
Yeah, that's correct. But only the sloppy quorum, whenever it picking up a node. So when we talk about n home nodes, okay, so that actually we're trying to understand. So yeah, it is perfectly fine. So it doesn't care what it is, but it has to store the value what it is getting from the write request, or maybe the read request also, right? I think only for write request, yeah.
Availability over consistency. That is what sloppy
For
quorum
read
is.
request doesn't matter. Yeah.
You
So it can pick
There
up
also,
any node and then just store it. Yeah. So it need not be the n home node. N home nodes are the in-sync replicas. So if the n-sync replicas for a particular key, if they are not there, it will go to some other node. Maybe in that Dynamo, it is the very next node from the home node, n home nodes. And then it keeps on looking for the neighbors one by one. Okay. Yeah.
makes sense.
Okay. So, I mean, still a little bit of a gap. Maybe let's finish this paragraph, then we can revisit the gaps. So, yeah, that's sloppy quorum. And once the network interruption is fixed, any writes that one node temporarily accepted on behalf of another node are sent to the appropriate home nodes. Right? This is called as the hinted handoff. The analogy here is that once you find the keys to your house again, your neighbor politely asks you to get off their couch and go home. Sloppy quorums are particularly useful for increasing write availability. Yep, I completely agree with that. As long as any W nodes are available, the database can accept writes. However, this means that even when W plus R greater than N, you cannot be sure to read the latest value of a key because the latest value may have been temporarily written to some nodes outside of N. This is the situation of sloppy quorum. Thus, a sloppy quorum actually isn't a quorum at all in traditional sense. It's only an assurance of durability. Namely, that the data is stored on the W nodes somewhere. There is no guarantee that the read of N nodes will see it until the hinted handoff is complete. Okay. But after the hinted handoff, at least they can make sure. Sloppy quorums are optional in all common Dynamo implementations. In React, they are enabled by default. And in Cassandra Voldemort, they are disabled by default. Okay. So
Yeah. So React follows almost everything as per Dynamo. Only Cassandra differs in some aspects, and one of them is this one.
So for the sloppy quorum to happen, I am imagining that there has to be a certain node sitting, not doing anything or not involved. So let's say in this example, there are 5 replicas. And in order for the sloppy quorum scenario to happen, there could be a scenario where there is another node sitting over here. I'm guessing. And let's say replica 3 goes down. So instead of writing to this guy writing to 1, 2, 3, it would write to 1, 2, and 6, which is the temporary node over here. And once the hinted handoff happens, it will take it from that 6 and push it to 3. Correct? Is my understanding correct?
So usually what happens is for leaderless, we have that consistent hashing ring, isn't it? So, and whenever we hash a key or maybe whatever that request will be, we hash that, and that hash value defines a particular node. So if it defines a replica 1 in this case, okay, so the home nodes for W are replica 1, 2, and 3. So usually your hash value will point you to replica 1. That will be your main home node, okay, to write, and then 2 and 3 are write replicas. So what it says is whenever your replica 1 itself, which is the main node, okay, so that itself fails. So you will still parallelly write to 2 and 3 also, but your replica 1's data will be replicated somewhere on replica 4 maybe. Usually it is always like that, 1, 2, and then it will go to the next one, which will be 4. And if 4 is also down, it will go to the replica 5, okay, and then it will go in a circle. And whenever your replica 1 comes back, because it might be in transient, it might be in delayed response for some reason, GC pause and all that stuff. So for that, when it is in transient, so that time it keeps on writing in a replica 4. So when replica comes back, 1 comes back, then all the data from replica 4 in that particular data set of that hinted handoff, it is actually copied back into replica 1.
Okay. So
that
essentially,
essentially
it's one of these nodes that will take up, but it says it is not the n home nodes. Right?
Okay, so if you're looking at that, but usually it will be a consistent hashing ring. Okay, so consistent hashing ring, just imagine we don't have these whatever it's shown as n equal to 5 replicas. Okay, so usually it will be 1, 2, 3, 4, 5, and again it is 5 is connected to 1, right? So the consistent hashing ring way. And for your W, the W is 3 in this case. So it will always go to 3 replicas for writing. Okay, so this W plus R, whatever they are showing for n is equal to 5 replicas, that is a different thing. But what I'm trying to do is I'm trying to use the same diagram and show that if it is a consistent hashing ring, how it will work. Okay,
I get the part. Yeah, I get the part in terms of the distribution of the nodes. When you use the consistent hashing as a reference, and I completely get it how they are distributed for 1, 2, 3, 4, 5. But when I'm reading the sloppy quorum elaboration, what it is trying to say that it will try to write on the nodes which is not part of the end nodes. So it is not part of these nodes.
Okay, then you can consider say, okay, if that is usually Dynamo doesn't talk about these things, but maybe if it is a replica 6 over there, then if your replica 1 is not available, then it will copy to that 6. And when the replica 1 comes back, then it will copy from 6 back to replica 1. So your replica 6 will be your hinted handoff.
Oh, right. That's what I was thinking.
Yeah, but usually what happens in a Dynamo also, it picks the first 3 nodes to write, and first 3 nodes itself for the read also. It's not going to do it this way it is shown over here. At least for the Dynamo paper, yeah. So this is slightly different. Therefore, I was confused and asking at that time. But this is a different way of representing. So if you do look at the consistent hashing ring, it will be always incident on a coordinator node or the node which your key lies in. So that will be your first node, and that will be your main node. And from there, it will always count to 3, 4, 5, whatever it is configured to.
But yeah, I agree with that. But yeah, since here for some reason
Yeah,
saying
yeah,
not
I understand because that's confusing when they talk about n home nodes and then you refer back to the same diagram,
Yeah.
because that is what the diagram is for this particular section. It makes sense absolutely. So in that case, we can assume that we have a replica 6 over here, and then the replica 6 because it has to be outside of this n home node, right? So then you actually assume that there is some replica 6 which will actually take that hinterland of data.
Yeah.
When the failed node comes up.
Mhm.
So yeah, that's what I so I was just trying to imagine, right? This node is basically sitting over here, which is not part of the end nodes.
Mhm. Yeah.
Wonder if there are any other writes happening to it or not, or
Yeah, it will,
not sure
because
how.
see, if it's a consistent hashing ring, so every node will be a main node for each and every hash range, So even if replica 2 is a replica 2 and replica 3 are replicas for a certain hash nodes, hash values of replica 1. So in certain cases, replica 2 will be, because it's a consistent hashing ring. So everyone will have to be a coordinator node for certain values of your whatever your data is. So everyone will have to be, and then the following two nodes, in this case, if it's W is equal to 3, they will be the replicas. So each and every node is important for a certain range of data. And the following twos will always be the replicas for the corresponding data. So all ranges are actually divided that way.
Mm-hmm.
Yeah, I mean, I think makes more sense if it takes 4 and 5, because at the end of the day, they are still part of the nodes. But I'm not sure what is the significance of this, whether why they would not consider the end nodes. Instead, go out for part of the nodes which are not part of the end nodes. Not sure why. Like you said,
I
going to
think
node 4
because,
and 5.
mhm,
I mean, I
because
get it. I agree with you that taking this guy as the third node, makes more sense. But this would take this guy's place, maybe. That this is down, so replica 4. So it would be 1, 2, 4 instead of 1, 2, 3. That
mhm.
makes a lot of sense here. But having an extra which is not part of home nodes, is something I'm mentally not able to
Right,
justify.
right. Yeah.
Cool, cool. I hope everybody is
I
getting
think
it.
every paper has its own way of implementing, I think. But this what they are showing here is more generic. And
Right.
this is what is supposed to be, because you have a quorum which has a write and read replicas separate and only one overlap and all those stuff. And so n may be a part of that ring. And then if there is something else, it might be outside of the ring, something like that, which is actually not at all a part of that n nodes. And then it is putting hinted hand of that. That might be a very generic case and a very idle way to do it. But I think Dynamo implemented its own way.
Cool. So interesting stuff regarding the stock quorum and the hinted handoff. Okay. Anybody has any questions, please pulse it out. Otherwise, we'll move ahead.
Yeah. This is just my reading, I might be wrong also. So anyone has more inputs, yeah, please share. It will be helpful for the group.
Okay. Cool. Cool. Okay, then moving forward. Multi-data center operation. We previously discussed the cross data center replication as a use case for multi-leader replication. Leaders replication is also suitable for multi-data center operation since it is designed to tolerate conflicting concurrent writes, network interruptions, and latency spikes. Cassandra and Voldemort implement their multi-data center support within the normal leaderless model. Okay, what they do? They implement their multi-data center support within the normal leaderless model. The number of replicas and includes nodes in all the data centers. That's what it is referring to, N, not just one, all the data centers. And in the configuration, you can specify how many of the N replicas you have to have in each data center. Okay, okay, makes sense, right? Each write from a client is sent to all the replicas regardless of the data center, but the client usually waits for the acknowledgement from a quorum of nodes which within its local data center so that it is unaffected by delays and interruptions on the cross data center link. The higher latency writes to other data centers are often configured to happen asynchronously, although there is some flexibility in the configuration. Okay. Right. So here it's basically waiting for the acknowledgement within its local data center. That's correct. So that is effective for this. The higher latency writes to other data centers are often configured to happen asynchronously, although there is some flexibility in the configuration.
Yeah, it makes sense, right? Because if the latency is higher and if we write it synchronously, so acknowledgement will be a problem. So there will be delays in acknowledging. So you actually do higher latency data center nodes, actually you do it async fashion.
If it is happening, what if it is happening asynchronously, then the latency should be low, right? Because you're not waiting for all the nodes to reply back. You are waiting for maybe one node or two nodes and then moving ahead. So ideally, the latency should be low in this case.
Yeah, they are saying that for if a particular data center node is of high latency, then you actually replicate with a async. That is what it's trying to say. So it will actually avoid that high latency issue. So it will be a low latency. Yeah.
Okay. React keeps all communication between the clients and the database nodes local to a data center. So N describes the number of replicas within one data center. Cross data center replication between database clusters happen asynchronously in the background in a style that is similar to multi-leader replication. Okay, cool. So it's subjective to the implementation, wherein sometimes it is one data center where the N is referred to, or among all the data centers in other cases. Cool.
So here it's saying multi-leader. Like in short, what in the multi-leader, like one leader is taking care of some of the replica, and how these multi-leaders, who will be the main leader? How to determine that? Like all the rights will come to all the leaders. Sorry, I got disconnected in between.
No, it's not multi-leader replication. He's saying similar to multi-leader replication. So in multi-leader also we have cross data center, right? Every data center will have a leader,
Yeah.
and we want to replicate to all leaders. And there are different ways to replicate it. It's slightly complex, but he's trying to use that analogy over here.
Mm. Okay. Similar
Okay.
to multi-leader replication. Okay.
Yeah.
So multi-leader, from what I recall, is the case where every data center there is a leader and there are followers, and the other data center will have a leader and there is a follower. But here it is leaderless, so there is no such one known node, designated node that is the leader. Unlike that, here the logic is that they are all n nodes across all the data centers, and at least from what I'm gathering here, the quorum mentions that it's all about the WNR. If W is 3, I'm guessing it waits for the right 3 to happen and it returns back. And accordingly, there might be some chain replication happening that we saw way back over there. And if the case that N describes the replicas within one data center, then again, it would be more like what is W, what is R. So if it's 3, so W is 3, that means you wait for at least 3 writes to happen here and acknowledge that the write has happened. and the rest would be just replicating to each other. I mean, that's like the fundamental leaderless
Correct, yeah.
that happens.
And also, if you
Yeah.
have multi-data center, it will be like the leaders will be scattered across data center also. And then some of them will have higher latency issues, because they are very far geographically. So that won't be a part of our acknowledgement. And then only the replication will happen async with them.
So multi-leader is the terminology here. It looks like for one data center there will be only one leader, right? It cannot have two leaders, otherwise a split brain or that kind of things happens, right?
No, split brain happens when there is a network partition.
Yeah, network partition will happen, and then two leaders
Mhm.
will be there, but one of them has to taken back, right?
Correct. If one goes, see, if you have two leaders, right? If one goes down, the other will automatically become the leader without having any election, right?
Yeah.
When you have more than two leaders, then election comes into picture, that Paxos, Raft, all those things, right? To avoid those issues. Split brain, what you are talking. Isn't it all?
Yeah. Yeah. So that is,
Mhm.
but the multi-leader, this is what I want to really understand. Multi-leader is like one leader per data center, huh?
Need not be, there could be more than one leaders in one data center also.
Okay, yeah, multi-leader is a different concept. Here we are talking about leaderless. Okay, so we have all our n nodes actually scattered across all the data centers, one. Okay, so that actually might have replication followers also. Okay, but that is a different model altogether. But what is saying that if you consider each and every node in a different data centers, then the one which actually has having a higher latency. So for that, it will be async replication, something like that. But that won't be a part of our quorum in that case then. So these quorums are configurable. Basically for Cassandra, they have the tunable model of consistency, right? So you can actually pick up which way you want. You can have a local hash ring, in the particular data center, or there will be the same hash
Global.
rings at many of the data centers. Yeah.
Mhm.
And also it can be a global. You can have one node and every data center. So that will form a ring also. So there are different ways to do it. But again, everyone will have its own complexities.
So
Yeah.
yeah, so I mean the difference here in case of leader and leaderless is that in leader there is a designated leader. It is like always that one node is the designated node where the write will happen always. But in leaderless, any one node can take up that responsibility, and every time that node will not be the node where the writes are always going to happen. It could be the next time some other node. The replication will happen once it comes to that one node, to the so-called follower replicas. But that's the main difference from what I gather, for leaderless and the leader based over here.
Yeah, that
Yeah.
is true. Yeah. Good.
Yeah, that is true. So now I want to understand more about multi-leader thing. So whatever you told, I have also that same understanding. Like in case of leader, the right will happen to the leader, and but in leaderless, like yeah, how many right replicas are there? Those guys will take the writing ownership. In case of multi-leader, I want to understand, like maybe I have missed that topic or
Yeah, it was already done. So now we are
yeah.
at the leaderless. So multi-leader is slightly complex, and most of the time it is not feasible also, they say, because multi-leader, what happens, leaders are designated different data center across the geography. And replication usually is in a sync way. Because if you do a sync replication, it is going to have an impact on your latency. So there are different ways to do it, and it's not very good feasible model. That is what they say. At the end, that is what it talks about. But it still applies, I think, and some of the uh, some of the products or maybe They are still using it. The server is still using it. But now we are at the leaderless. So there is no leader concept like that. Yeah. So this is what the diagram talks
That
about here.
chaining thing we were trying to understand, that comes in the multi-leader. That
Chaining thing
sequence.
is just like any chain replication, no?
Yeah.
So you don't have to have a multi-leader. It is all of them. They will be sequentially updated one by one.
Yeah. Okay.
It was like one node fails, subsequent node can pass it, right?
Yeah.
That is what chain replication was.
Yeah. Okay, I will go through.
So multi-leader so in one data center we can have more than one leaders, right? That's
Yeah, I
correct.
think so. Yeah, sure. Yeah, it should be possible. See, even region-wise, you have many data centers, and in a single
Correct.
region also. Yeah, and they are very tightly coupled also. So they are almost same. The latency and everything is very competitive in a certain region. So they are completely tight bounded. And again, you have region to region different replications.
Data center.
Yeah, I have a question. What do you
Sure.
think about such use case? We have just two nodes. Yeah, just two nodes. As I understand in LeaderOS, yeah, okay, we have two nodes. Even if we use LeaderOS and multi-leader, they will be symmetric. Yeah, all of them will be able to accept to write a write request. Yeah, but if we write to any node and this node have to follow condition write plus read more than 2, yeah, it means that if it's leaderless in case of two nodes, we have to write to both nodes, yeah, but if it's multi-leader, we are okay to write just a single leader.
Okay.
Yeah, what do you think?
So you are saying like two nodes are there, and in case of a leaderless, I understand. In case of multi-leader,
Yeah.
again you are saying only one node is going to take the right.
Yeah, I think so. Yeah.
Yeah, that is what actually the definitions talks about. Because all our leaders, so your write request will go to your closest data center, isn't it? So that will be your leader. So that leader responsibility is to replicate it with the other leaders. So that is the difference between the multi-leader and the leaderless. I think, yeah, Nick got a good point. So he's trying to show exact what is the difference between both of them.
And it's more to do with the level of acknowledgement. In the multi-leader approach here, the user is just waiting the acknowledgement of the leader here. The rest of the job is of the leader to replicate with the followers. Whereas in leaderless, we are talking about a quorum that essentially we say that, okay, it should write or read the acknowledgement for 3 number of nodes, 2 number of nodes. That's the acknowledgement in the leaderless thing.
Correct.
That's the quorum part.
Yeah. And therefore that hinted handoff comes into picture, because if one node fails, so you are failing the quorum, right? So you're only getting a response from 2. But then there is another way they say you use a hinted handoff, whereas they pick up another node, write it to data set, and that node will actually respond back. So you still have 3 acts you can take, and then you can respond back to your write request. So it completes that quorum concept there.
Okay, so I understand this multi-leader is what Nick told. It's kind of single leader only, right? It's just replicating to other leader. I mean,
yeah, but it has an additional responsibility. Whenever it is written, it needs to replicate in there will be different modes to replicate. So one mode will be to do a sync replication with the other leader.
Okay, yeah. I mean, extra responsibility it has got. Yeah, got it. Okay.
Yeah. But I don't know that when it goes and replicates, at that time, if it is not able to replicate because of the second leader got failed, so how things happen over there, because, or maybe if it is written in the first leader and this leader fails, and before he writes to the next leader, this leader doesn't come back, and the next leader is only going to take the responsibility of the other request. So there might be a data loss and all that. I think that there are some issues in that also, right?
Mm-hmm. Yeah.
So So I hope that part is clear, right?
Yeah, this
Yeah.
is clear to me. Yeah.
The more we dig, the more things are coming.
No, it's the more confusion comes up. Yeah.
Becomes
Yeah, but it's a good discussion. Yeah, I like that. Yeah, because that multi-leader is always some, very difficult thing to really, clear up with each and everything. Yeah.
because there only those algorithms comes right again. How what happens? Yes.
Hmm.
Okay, moving on. Detecting concurrent writes. Dynamo style databases allows several clients to concurrently write to the same key, which means that conflicts will occur even if strict quorums are used. The situation is similar to multi-leader application handling write conflicts. Although in Dynamo style databases, conflicts can also arise during read repair or hinted handoff. The problem is that events may arrive in a different order at different nodes due to variable network delays or partial failures. For example, figure 5-12 shows two clients A and B simultaneously writing to a key X in a 3-node data store. Okay. Node 1 receives the write from A. This is node 1. Okay, receives the write from A, but never receives the write from B due to a transient outage. So this is B over here. Did not receive it. Okay. Node 2 first receives the write from A. This is the node 2. Then the write from B. Okay. And similarly, node 3 first, okay, this is different. Here it receives the write from B first. Okay, this is the first, and then from A. Okay. So the interesting situation here is that XA is being written by client A and client B is writing it as B. This guy reaches A here, but at the same time, B is failing to register the change here and node 1. Then for node 2, first A is getting registered, then B is getting registered. And for 3, B is registering first and then A. Okay. That is the concurrent write scenario. If each node simply overrode the value of for a key whenever it received a write request from a client, the node would permanently become inconsistent, as shown by the final get request in figure 5 here. Yeah, because now every node has a different value in a way. Right. So as shown in the final request, node 2 thinks that the final value of X is B, whereas other nodes think that the value is A. And in order to become eventual consistent, the replicas should converge towards the same value. How do they do that? One might hope that the replicated databases would handle this automatically, but unfortunately, most implementations are quite poor. If you want to avoid losing data, you, the application developer, needs to know a lot about the internals of your databases conflict handling. We briefly touch some techniques in handling write conflicts. Before we wrap this chapter, let's explore the issue a bit in more detail. Okay, last write wins, discarding concurrent writes. One approach for achieving eventual convergence is to declare that each replica need only store the most recent value and allow older values to be overwritten and discarded. Then as long as we have some way of unambiguously determining which write is more recent, and every write is eventually copied to every replica, the replicas will eventually converge to the same value. Okay, I guess this is very clear. The recent value takes precedence over the older one. I'm sure there's a way they are recording the recent and old also. As indicated by the quotes around the recent, this idea is actually quite misleading. In example 512, neither client knew about the other one when it sent its write request to the database nodes. So it's not clear which one happened first. Okay, interesting. In fact, it doesn't really make sense to say that either happened first. We say that the writes are concurrent, so the order is undefined. Okay, so this is contradicting what I was thinking. The order is undefined, it's concurrent, there is no first, last, recent order. Even though the writes don't have a natural ordering, we can force an arbitrary order on them. For example, we can attach a timestamp to each write, pick the biggest timestamp as the most recent, and discard any writes with the earlier timestamp. This conflict resolution algorithm is called last write wins, LWW. It's the only supported conflict resolution method in Cassandra and an optional feature in React. LWW achieves the goal of eventual convergence but at the cost of durability. Okay. If there are several concurrent writes to the same key, even if they are all reported successful to the client because they were returned to W replicas, only one of the writes will survive and the others will be silently discarded. Moreover, LWW may even drop writes that are not concurrent. Okay. There are some situations such as caching in which lost writes are perhaps acceptable. If losing data is not acceptable, LWW is a poor chance for choice for conflict resolution. That's a very valid point. There's a pro and con, obviously. The only safe way of using a database with LWW is to ensure that a key is only written once and thereafter treated as immutable, thus avoiding any concurrent updates to the same key. For example, the recommended way of using Cassandra is to use a UUID as the key, thus giving each write an operation a unique key. So this would be more like an incremental unique key, I'm guessing, over here.
So here in this paragraph, what they are saying, like they are using LWW, last write wins, right? Or this last write wins or timestamp ordering events is kind of same, right? Like the last write is as per timestamp, which is who is writing at the end. That others will be discarded, and the last one will be the persistent one. So my question is, yeah, if losing data is not acceptable, we are doing that as locking, right? Like we do lock, we do not. How we will handle that? We will be losing some data, right?
No. For that, he's saying the application developer is more knowledgeable. He is the best person to take a decision call on it.
Manually, that is done. Yeah.
Yeah, it will be more of a conflict resolution. Either you use those CRDTs and all that, or you actually do give it back to the application developer.
But that data, it will not be persisted till that point. How in the gate we get this three view? Those are somewhere saved. Somewhere they might be saving it, right? So that we are able to see that we are fetching it.
Yeah, because each and every replica will have different values. So they are using their version vectors and version clock. So all the data for a particular node will have a reference version vector and version clock, something like that. And all those things, when actually you have to resolve a conflict, you give the data back to the client, and the client will actually consider if it's like that shopping cart, right? You have added something, you deleted something, and then you have added something, So then you are the best person to know what you really want at the end.
But those whatever who has written first, where it is getting stored? From
It will be
here?
in different replicas the way he showed about in the diagram. Everywhere it goes to a different place, and therefore you have different values, right? Here he's showing your node 1 as A, node 2 as B, node 3 as A, isn't it? So these are the different values. So you give all these values back to the client, then he will understand, oh no, I'm more concerned about B only, and you just discard A's, or I
So
am
that
interested only in A.
yeah,
Mhm.
coordinator node will be giving the value to the client. Who
All of them together. Because whenever you act it, at that time you'll pick, whenever you give a read request, so you'll get all the data from all the nodes, and then you'll have to return that back. If it is same, you don't have to return, but if it is not same, then you have to return the conflicted one. That is what I think.
But client has to ping all these three nodes, is it? Like internally it is pinging or?
Well, whenever a read request comes, it will internally go by the design, it will go to all the three nodes. That is what the quorum is. No?
Mm-hmm.
Okay. Okay. So I hope that helps to understand. Uh, uh, so yeah, it's mostly the timestamp or the UUID which was mentioned here. I guess somewhere. Yeah, Cassandra is using as the key to have a unique key associated.
So I wanted to understand from the code perspective, like from the configuration perspective. Somewhere, like for Cassandra or for other things, this is configuration that read writes. Those are configuration based, right? That I understand it. But how internally they are doing it? Like they are trying to pull the data from there.
Cassandra uses that last write wins. So whichever is the last write, the same value will be across all the nodes. So Cassandra will actually don't have that. He will resolve its conflicts on its own. But the Dynamo paper says it doesn't do that if it's something like a Dynamo style database or a data store. So for that, you'll have to use a different mechanism.
Yeah, so that's the communication between nodes. In case of last write wins only, suppose in communication, when they are settling for the last value, all the nodes, the communication between nodes has to be happen, right?
Yeah, it should. Uh,
That how it does happen, like what are the protocols there? I just wanted to know
yeah,
that, but
Yeah, that is what he says. You need to actually read the database internals before actually entering in this. Yeah.
yeah, it's deep. It's very deep. So,
Yeah.
I mean, I
I
obviously
agree. See, what she is trying to say is now, even if you have a live straight events, all the nodes will have different timestamp when the data is
correct.
coming in. So
Correct.
if you pick up at the last one, say, okay, this is my timestamp for this node, I'm updating. So I'll go, how I'm going to go back and update for the other three nodes, and how I know that this is a part of the quorum, these nodes. Is there some way? I think maybe the coordinator node for that particular value will surely know about it, because all these nodes actually are in sync with each other about their configurations based on that gossip protocol. So you'll surely be able to find out which actually your hash value is coming from and which is your coordinator node for that particular write. So those things will surely be there. So you are saying that how again will there be one more hop when I write to a particular node, which will be the last node maybe instead of 1, 2, 3. When the last write comes on the third one, will it go back to 2 and 1 again? That will that be two more additional hops? Yeah, I don't know about that.
So, from what I recall, if there is such a ambiguity in the values, I think so. During read, when it sees that it's reading from three replicas and it sees that there is some ambiguity in the data, and it will pick up the data with the latest timestamp. I believe either at that time it should do something to have the other replicas get the latest value. I think there are two things we spoke, right? Read, repair, and anti-entropy.
So you are
Before.
saying during it will happen at the read repair.
I'm just imagining the possible approaches. Either there should be something running in the background to check and update this. Either one, or either two. When it reads, that time it will trigger a kind of update that okay, this is the latest one. Hence, this should be there on the other replicas also. I'm guessing that.
Yeah, that makes sense. So that during read repair, it will again go back and parallelly it'll look for which is the latest timestamp based on it, and then actually it will parallelly replicate for the other nodes. Yeah, so that will be one hop again. And if it is not read frequently, so then anti-entropy will do that.
Yeah.
Yeah, that's valid point. Sir, yeah, thanks.
Okay, cool, cool. So I hope the point is clear.
Yeah.
Cool, cool. Then that happens before relationship and concurrency. How do we decide which two operations are concurrent or not? To develop an intuition, let's look at some examples. Okay, so should we take this now or should we take this later? Big example.
Yeah. Next time we can have it, right? It's very big topic, right?
Yeah, thinking that. Do you guys feel we should take it next time? Are we all on the same page?
Yeah, fine.
Okay.
Yeah.
Okay. Cool then.
Sure.
Once again, thank you
Santosh,
everyone.
you can stop the recording. I think.